How do you transform ordinary structural steel into the high-strength steel we use to build today's iconic skyscrapers? Welcome to the ArcelorMittal International channel, where we talk all things structural steel. Let's talk ASTM A913, a high-strength, low-alloy structural steel with a yield strength up to 80 KSI. This video is mainly going to talk about the production differences between A913 and the industry standard A992. So let's start at the beginning. Recycling. A913 is made with 98% recycled scrap in an electric arc furnace. Once the scrap is melted, it's cast into a form called a beam blank. The blank is fully cooled and put in storage at the mill until its scheduled roll date. On the day of the scheduled rolling, the beam blank is then reheated so it can then get rolled to its final shape size. Up until this point, the process for A913 and A992 is essentially the same. It's what happens next that transforms ordinary steel into the highest strength steel section in the world. That next step is what we call the quenching and self-tempering process, or QST for short. It is an inline process, which means it takes place on the same production line immediately after the roll cycle. In the QST process, hot steel sections around 1600 degrees Fahrenheit are subject to swift, controlled cooling, which is halted before the cross-section's core is entirely affected. The residual heat within the core facilitates self-tempering as that heat migrates from the core to the outer surface. The QST process introduces additional grain refinement into the microstructure of A913. This additional grain refinement is what gives A913 its heightened yield strength. We can see this visually as well. While both A992 and A913 are produced with a thermomechanical rolling process, the effect of QST on the grain size refinement is evident for A913. Interested in learning more? Subscribe to our channel to stay up to date with the latest and greatest in structural steel. Bye for now.